What if the most powerful and violent place on our entire planet was not on land, not in any war zone, not in any desert or frozen wasteland, but silently waiting beneath the ocean, hidden under miles of dark water, quietly building entire new worlds while the rest of us went about our ordinary lives completely unaware? Most people think of volcanoes as dramatic mountain peaks spitting fire and ash into the sky, Vesuvius burying Pompeii, Krakatoa shaking the entire earth, Mount St. Helens blasting its own top off in a cloud of grey destruction. Volcanoes are loud. Volcanoes are visible. Volcanoes announce themselves. That is what most of us believe. But here is the staggering truth that most people never learn in school. Roughly 80% of all volcanic activity on Earth does not happen on land at all. It happens underwater. Silently. Invisibly. In the crushing darkness at the bottom of the sea, thousands of feet below the surface, where no sunlight reaches and no human eye has ever naturally looked. The ocean floor is alive with fire. Beneath the waves lies the most volcanically active landscape on our entire planet. A vast system of underwater mountains, ridges, and rifts stretching over 40,000 miles around the globe like the stitching on a baseball, constantly erupting, constantly building, constantly reshaping the face of the Earth in ways that take thousands of years to see from above. And hidden within this extraordinary underwater world are individual volcanoes so large, so powerful, and so geologically remarkable that they make the most famous land volcanoes look almost modest by comparison. This is the story of how scientists discovered one of the most extraordinary of them all, and what they found when they finally looked closely enough. The journey toward understanding underwater volcanoes really begins with one of the greatest scientific revelations of the 20th century. The theory of plate tectonics. For most of human history, people assumed the ground beneath their feet was fixed, permanent, and essentially unchanging. Mountains were mountains. Oceans were oceans. The continents sat exactly where God or nature had placed them and stayed there. It was not until the early 20th century that a German meteorologist named Alfred Wegener began noticing something deeply peculiar about maps of the Earth. The coastlines of South America and Africa, he observed, fitted together like the pieces of a jigsaw puzzle. The same fossil species appeared on continents separated by thousands of miles of open ocean. The same rock formations matched up across continents that had no business sharing geology. Wegener proposed the radical idea that the continents had once been joined together in a single giant landmass he called Pangaea, and had slowly drifted apart over millions of years. The scientific establishment laughed at him. Politely at first, then not so politely. The idea that solid continents could drift across the surface of the Earth like leaves floating on a pond struck most serious scientists as physically absurd. Wegener died in 1930 on an expedition in Greenland, largely dismissed by his peers, his theory considered an interesting curiosity at best and an embarrassment at worst. But the ocean had not finished making its case. In the 1950s and 1960s, oceanographers began systematically mapping the ocean floor for the first time in history, using sonar technology originally developed for military submarine detection during World War II. What they found stunned the entire scientific world and vindicated Alfred Wegener beyond any possible doubt. Running down the middle of the Atlantic Ocean, and continuing through virtually every ocean basin on Earth, was an enormous underwater mountain range unlike anything seen on land. They called it the Mid-Ocean Ridge System, and it is the longest mountain range on Earth, stretching over 40,000 miles around the globe, almost entirely hidden beneath the sea. At the center of this ridge runs a deep crack, a rift valley, where two tectonic plates are slowly pulling apart from each other, and where molten rock from deep inside the Earth is constantly pushing up through the gap, solidifying, and building new ocean floor. This was the engine that had moved the continents. This was the mechanism Wegener had intuited but could not prove. The ocean floor was not permanent. It was not fixed. It was being constantly created at the mid-ocean ridges and constantly destroyed at subduction zones where plates collided and one dived beneath the other. The solid Earth was, on geological timescales, as fluid and dynamic as the ocean above it. And the underwater volcanoes lining the mid-ocean ridge system were the furnaces powering the whole magnificent machine. But the mid-ocean ridge volcanoes, extraordinary as they are, were not the discovery that truly electrified the scientific world and changed everything researchers thought they knew about life on Earth. That discovery came in 1977, in the cold deep water near the Galapagos Islands in the eastern Pacific Ocean, and it arrived with the force of a genuine scientific revolution. A team of scientists from the Woods Hole Oceanographic Institution in Massachusetts had been studying heat flow patterns in the ocean floor near the Galapagos Rift, a section of the mid-ocean ridge system running through the eastern Pacific. Their measurements suggested there should be areas of unusually high heat output in certain locations on the ocean floor, places where hot water was being pushed up through cracks in the rock. They wanted to see what these areas looked like. They lowered a towed camera system to the ocean floor and waited. The photographs that came back changed biology forever. Instead of the barren, cold, sediment-covered desert that scientists had always assumed made up most of the deep ocean floor, the cameras revealed something almost impossibly alive. Clustered around what appeared to be cracks in the ocean floor, vents from which shimmering, superheated water was rising in what looked like ghostly transparent columns, was a riot of life unlike anything science had ever documented. Giant tube worms, up to 8 feet long and as thick as a man's arm, swaying in the current from the vents. Enormous white clams the size of dinner plates. Beds of mussels. Swarms of blind shrimp. Spider crabs picking their way across the rocks. An entire ecosystem, dense and diverse and thriving, in the total absence of sunlight, at depths where the pressure would kill a human being instantly. The discovery was so unexpected, so far outside anything scientists had imagined possible, that the researchers aboard the ship could barely believe what they were seeing. The entire foundation of biology at that time rested on the assumption that all life on Earth ultimately depended on sunlight, on photosynthesis, on the energy of the sun converted into sugar by plants and algae and passed up through the food chain. Sunlight was not just important to life. It was considered the absolute prerequisite for life. Nothing could live without it. And here, in the deepest, darkest, most sunless corner of the ocean, surrounding an underwater volcano, was an entire community of living creatures that had never seen sunlight in their entire evolutionary history and appeared to have no need for it whatsoever. These creatures were living on chemosynthesis, the biological process by which certain bacteria convert the chemical energy in hydrogen sulfide, a toxic gas that pours from the hydrothermal vents along with the superheated water, into organic matter. The bacteria formed the base of this entirely new food chain. The tube worms harbored colonies of these bacteria inside their own bodies in a remarkable symbiotic relationship. The clams and mussels filtered them from the water. The shrimp and crabs ate everything else. It was a complete, self-sustaining ecosystem powered entirely by the heat and chemistry of the Earth's interior, independent of the sun, independent of the surface world, thriving in conditions that had always been considered incompatible with life. The implications were staggering. If life could exist here, around a volcanic vent in the crushing darkness of the deep ocean, with no sunlight, in near-boiling water laced with toxic chemicals, then life could potentially exist almost anywhere. On the moons of Jupiter and Saturn, where subsurface oceans are thought to lie beneath thick crusts of ice, warmed by tidal forces rather than sunlight. On Mars, where ancient hydrothermal systems may once have existed beneath the surface. In environments that scientists had always dismissed as sterile and lifeless. The discovery of hydrothermal vent ecosystems did not just rewrite the rules of marine biology. It rewrote the rules of astrobiology, the study of life beyond Earth, and is considered to this day one of the most important biological discoveries in the history of science. But the story of underwater volcano discovery did not stop in 1977. It accelerated. As deep-sea exploration technology improved through the 1980s and 1990s, as remotely operated vehicles became more sophisticated, as submersibles could dive deeper and stay down longer, as sonar mapping revealed the ocean floor in ever greater detail, scientists began finding underwater volcanoes of truly astonishing scale and behavior. One of the most remarkable of all was discovered in the western Pacific, in a remote section of the ocean floor known as the Lau Basin, near the island nation of Tonga. In 2009, a research expedition led by the National Oceanic and Atmospheric Administration, NOAA, sent a remotely operated vehicle called Jason to explore an underwater volcano named West Mata, located about 120 miles southwest of Samoa at a depth of approximately 4,000 feet. What the cameras transmitted back to the surface ship was the first ever live footage of an active deep-sea eruption, and it was breathtaking beyond any previous expectation. West Mata was not a dormant, sleeping volcano. It was erupting continuously, violently, and with extraordinary intensity. The ROV's cameras captured rivers of glowing red and orange lava flowing across the ocean floor, boiling the surrounding seawater and producing massive clouds of gas and superheated water that rose in shimmering columns toward the surface. Chunks of molten rock, some of them the size of basketballs, were being hurled from the eruption site, arcing through the water like slow-motion fireworks before landing on the surrounding seafloor and hissing as the cold seawater instantly chilled their outer surfaces. The colors were extraordinary, deep red and orange lava against the absolute black of the ocean floor, surrounded by clouds of white and gray mineral-rich water. The ROV's lights catching the whole volcanic spectacle in images that looked more like science fiction than documentary footage. And surrounding this violently erupting volcano, living in conditions that would seem to make life absolutely impossible, were animals. Shrimp. Hundreds of them, clustering near the vents as the volcano erupted around them, somehow surviving the heat and the acidity and the volcanic gases. Scientists watching the footage from the surface ship stared at each other in silence for a long moment before anyone could find words. Life, again, in the most impossible place imaginable. Clinging to an erupting underwater volcano at 4,000 feet depth, surrounded by liquid rock and boiling water, going about their business with the same stubborn tenacity that life seems to display everywhere science looks in the deep ocean. West Matter turned out to be the shallowest and most accessible of a whole chain of submarine volcanoes in the region, many of them far larger and more geologically significant. Further exploration revealed that the Western Pacific alone contains hundreds of submarine volcanoes, many of them active, many of them producing hydrothermal vents, and many of them hosting unique biological communities that have evolved in complete isolation from the rest of the ocean. Each vent system, scientists have discovered, is essentially its own island, geographically isolated from other vents by miles of cold, dark, inhospitable ocean floor, and therefore home to species found nowhere else on Earth. One of the most extraordinary individual discoveries in recent years has been the gradual revelation of the true scale of Tamu Massif, a massive underwater shield volcano located about 1,000 miles east of Japan in the northwest Pacific Ocean. Tamu Massif was known to oceanographers for decades, but it was not until 2013 that researchers from the University of Houston, analyzing drill core samples and seismic data collected from the site, announced that this single underwater volcanic structure was likely a single shield volcano, and that it was enormous. Measuring approximately 280 miles across and covering an area of about 120,000 square miles, Tamu Massif is roughly the size of New Mexico. At the time of its identification as a single volcanic structure, it was considered the largest individual volcano ever identified on Earth, larger than any land volcano by an almost incomprehensible margin, and comparable in scale to the largest volcanoes in the entire solar system. The announcement sent a ripple of excitement through the geological community. Subsequent research has raised some scientific debate about whether Tamu Massif is truly a single volcanic edifice or a more complex structure. But even the more conservative interpretations leave it as one of the most remarkable geological formations ever discovered on our planet. An ancient giant that erupted approximately 145 million years ago, during the age of the dinosaurs, and has been sitting silently on the Pacific floor ever since, largely unknown, as the surface world above it went. Through the rise and fall of dinosaurs, the emergence of mammals, the evolution of human beings, and the entire span of human history. What the story of underwater volcano discovery ultimately tells us is something both humbling and thrilling about the nature of scientific knowledge. We live on a planet that is still, in many of its most fundamental aspects, profoundly unknown to us. The ocean covers 71% of the Earth's surface and reaches depths of nearly 7 miles. The vast majority of it has never been seen by human eyes. The vast majority of the volcanic activity that shapes and reshapes our planet happens in that unseen world. The ecosystems that cluster around the hydrothermal vents of underwater volcanoes represent some of the most ancient, most resilient, and most biologically unique communities on Earth, and scientists have barely begun to catalog them. Every research expedition to the deep ocean returns with something new. A new species, a new vent system, a new volcano, a new chemical process, a new clue about the origin of life on Earth, because many researchers now believe that life itself may have first emerged not in sunlit shallow waters but in the hot, chemically rich environment of a hydrothermal vent, billions of years ago, in exactly the kind of place that was considered impossible for life until scientists were humble and brave enough to look. The underwater volcano does not announce itself. It does not roar or shake the ground or paint the sky with ash. It simply burns, quietly and constantly, in the dark at the bottom of the sea, building new rock, heating the water, feeding entire worlds of creatures that have never seen the sun, and reshaping the planet with a patience and a power that makes all of human history look like the blink of an eye. And somewhere down there right now, at this very moment, in the crushing darkness miles below the surface of the Pacific or the Atlantic or the Indian Ocean, a new volcano is erupting. New rock is being born. New life is clustering around the warmth. And the Earth is doing what it has always done. Quietly, powerfully, magnificently, building itself anew, whether anyone is watching or not.